Hello, everybody. This is going to be a quick video that describes the phasor object. So let's just dig into it. So to start off, let's talk about coordination of parallel tasks. So since the beginning of this class, we have been creating tasks and running them in parallel. How do we do that? So quickly pause if you need to, or just think of what is the mechanism for how we can run things in parallel. Okay, we're back. And so hopefully a lot of you have referred to async. That is how we're doing things. Uh, we've had the executor server submit or thread start, silk has spawn. Everyone has a way to start a task. The next question is, what is a mechanism we've used to coordinate those tasks? And so just pause if you need to, or just answer. We're back, and hopefully a lot of you have come up with finish as at least the sort of the first thing that we did, right? So our first coordination of parallel tasks was when, remember the old sum ages or sum range or whatever you want to talk about it, where we had the subsums, we had two indices for it, and we would spawn a task that we would async this part, run this in the continuation, and then we would need to finish them up before we added them together, because otherwise there could be a data race and all sorts of other stuff. So finish is a way in which you can sort of coordinate tasks in a very straightforward way. Okay, and so ever since and that's not just us in this class, but ever since people with computing or even other things we'll talk about began spawning tasks and sharing resources, we needed to coordinate them. This includes things like railroads. Ever since they've been, going to have to share this track, right? When two tracks come together to be one, they've had to coordinate that and to make it so that you don't have train crashes. You want to make sure that only one can access this track at the same time. This is semaphores, which there's not only is there a semaphore in trains, there's a semaphore in computing. If you look at Java util concurrent, they have a semaphore. They have a bunch of things in this package. If you look at the package, there's a bunch of things. I don't know why exactly that won't click for me, but I'll just click at it. Oh, it's going just slowly. There's a bunch of different things, cyclic barrier, countdown latch. There's a bunch of different things, including the phasor, which we will talk about today in more detail. This is just another coordinating object. If you look at its docs, like I was just clicking on, it's a reusable synchronization barrier. It's similar to these other guys, but has more flexible usage. It's kind of a very nicely evolved thing. It's really good for iterative averaging. We're also going to use it for some other things. It's a very nice feature that was first developed by Sarkar and others on the X10 team. And think of the phasor the way the bad analogy of the day thing is, think of the phasor as your friend who is really good at organizing things. A lot of us have somebody who's always the person who's like really good at organizing the weekend's events. I want you to imagine that the phasor has this plan. We're going to meet up at Donnie's, and we're going to go to dinner, then we're going to go to bowling, and we're going to go to drinks, right? Or we're going to go karaoke or whatever all these phases are. And there's these different parts of the night, and it's all planned out. And I want to sort of know is like, what do we all need to do if we want in on this plan? This is going to be Friday night's plan. What do we need to do? What's the first thing we all need to do? Now pause while you think about this. Think about your friend who serves this incredibly useful function. And you should thank this person the next time you talk to them. So I'll pause and then we'll come back. All right, so hopefully a lot of you have come up with the idea that we need to RSVP, right? If Faye is going to be organizing this whole set of things, we need to tell the phasor up ahead of time, like, I'm coming. So when we go to meet up at Donnie's, before we go to all get in our Ubers and go to dinner or whatever, we're gonna, like, I'm coming, so that everyone knows to wait for you. And like, once everyone's RSVP'd, you sort of know, like, all right, everybody's finished with dinner, everyone's gone bowling, everyone's bowled their 3 games, we're moving on, right? And so what phasor has for this sort of thing is the register method. And each task that's going to be in on this party needs to register. Now there's also bulk register, so you can be like, all right, I got 8 tasks, like register 8 of them. There's also a way to construct it directly from the phasor. You can tell how many parties you're going to need, and it's sort of the equivalent of, like we said, phasor 8 is the equivalent of calling register 8 times. Okay. The other thing we need to do is we need to inform when we have arrived at a particular phase and possibly wait for her, wait for her to let us know it's time to move on. So for example, like when we actually show up at Donnie's, we need to say, like, I'm going to arrive and I'll wait for everybody else. When you actually get to the restaurant, you'll sort of signal that you've arrived and that you're going to wait for everybody to move on to bowling and all sorts of other stuff. So this is a sort of thing where there's a method that does, both parts of it. I've arrived and I'm going to wait to move on. I finished my work, so I've finished my dinner, right? And I'm going to wait for everyone else before we all go bowling. And so this is called arrive and await advance. And it just signals to everyone that it's time, I'm ready to go, and we can go ahead and roll. And what this means is for things like the iterative averaging example, we have a sequential outer loop and a parallel inner loop, right? And the parallel inner loop then does some work. This might be a for loop also, where you went through went through the slice or whatever, but fundamentally there's a sort of number of iterations on the outside and then some parallel loop. You can turn that into this phase version by creating a phaser, registering for each task, and just flipping the parallel loop on the outside, doing the sequential loop in here, doing that work, which could again in turn be a loop. And then you say, I've arrived in await advance before I move on to the next version of this sequential loop, and you build essentially the same parallel program, but with less overhead, okay? Now my question for you is, what is the phase for iterative averaging? And I'll pause for you if you want to take a moment to think about what is the phase in this situation, if you think of what iterative averaging is like. So let's, so we're back, and I'll type this out really quickly. If you think about it, there's like 4 each iteration of iterative averaging, right? There's another one which is like 4 each index in the array. Now we obviously don't have to do the 0th one and the last one, but in the array, we're gonna like average with both neighbors. And in this situation, this is the one that can be parallel, right? This is the one that has to wait for, like each one averages with their neighbors from the previous round, right? So it has to wait for it to complete, right? This is the work. This is sort of this parallel inner loop, and this is the other one. And so the phase is this iteration of the iterative averaging, right? Like the number of rounds that we're going to do, each one is the additional phase, right? When we turn it into the phased version of iterative averaging, we flip these inside out, make the phaser. And usually we don't need to really keep track of the phase for this very simple one, because arrive and await advance doesn't need to know it's keeping track of itself. When we do some of the more precise ones later, or when you're doing more precision things, you need to know what the phase is. So I think it's a good idea to talk about, like, it's this iteration for each I, I in iteration, right? Like that I is going to be the phase you would pass in to the phaser if you needed to. All right, so let's just press on. Let's talk about some more precise control, phaser control. One of them is for this fuzzy version, right? Where, in the simple example that I've given on a couple of the quizzes, or a quiz, and we'll talk about more, is, the shared work versus the local work. And the shared work for iterative averaging is if you slice this up, and this is an 11 along array, we slice it into 3 slices, 3 groups. And the outer 2 don't have to be averaged because they're on the end. You can see these 3 slices, the only ones that any neighbors are caring about are the one on the edges, right? So this is the shared work would have to be done first. You do that first, then you can do your local work. I want you to imagine that instead of this being 11 long, it's like 100 million long, right? And so there's just one on each of the edges that needs to be done. And then all this local work in the middle could be done next. And so that allows us to do this fuzzy or split phase barrier kind of thing, where instead of just having this thing where the parallel loop, sequential loop, this work, and then arrive and await all in once on the phaser, you can say, oh, all right, we're going to split the work up, do that shared work first, right? So the work just on the edges, right? We'll do that first. Then we'll say we've arrived. Anybody who's waiting on us can go, and then I'll do all my local work. And again, it's less motivating here because there's only 3, but I want you to imagine 1 million in here where there's just 1, right? Do that local work, then you'll wait on your neighbor, right? And so this allows you to do this fuzzy split phase situation. And that's how that works. We just split both the work up into 2 spots, and then the arrive and the wait advance get split up. Okay. For this, we have arrived. This is basically saying, I'm here, right? And other people who might be waiting on me can go. A wait advance is like, I'm literally going to wait on someone else, some phaser. I'll wait for the phaser to achieve this phase number. And so you just sort of split it up into one. The bonus sort of advanced usage for this is, let's say that this is phase plan and Walter is not interested in anything else. Walter just wants to show up. Walter's only interested in bowling. Could use this await advance on some phase number and just like make his own task, not register or anything, and just say, I'm going to wait for Faye to reach phase 2 before it moves on. There's a little bonus bit of interest here in that if you are awaiting advance on a phase, and let's say you wait advance phase num 2, and it's already 1 or 2, right? That works as you might expect. Or if it's 7, it will just let you go also. That's also fine, right? But if it was 0, it would just return immediately and tell you that it didn't work. So we actually built this thing to await advance per phase, where it actually just literally just keep going if it returned the phase was too early. This does not come up too often. Some people have built some of the studios where they had to do it this way. So just to alert to you that this utility exists for you. Sometimes we'll want to use more than one phaser. That comes up in a couple of studios, both in the point-to-point versions. You're going to make multiple phasers. This is totally fine. It makes sense that you would need that you can make more than one phaser if that's what you need. And point-to-point iterative averaging uses this, as well as the legged race ends up making more than that. In the legged race studio, you end up building these many, in this one you have one, if there's 50 people, you have one 51-legged race where everyone's bound together. In this one, you would have 25 3-legged races. Obviously, you're going to need more phasers to coordinate this, but you'll be less waiting around on everybody. So it'll go better, but you have to make more phasers. The other thing we're going to do is build up a pipeline, and that ends up using more than one phaser also for you to coordinate it. So with that, I'll just leave you with the documentation to phaser. It's a very useful coordinating device. It's part of the standard Java library now. It was originated out of X10. And it's similar to some other things. It just has some nice syntax to it. This also gives you the quick links to how to create them, how to RSVP to them. This is called registering, where you can say how many people, how many tasks you expect to be waiting on each phase, or how many will arrive on each phase. There's the simple usage, which is to arrive and await advance. But then you can have more pinpoint control, where you can call arrive and await advance separately. And again, this phase has a little bit interesting semantics where it returns immediately if it's not in that phase or the previous one, and you may want to just call this phaser utilities one. And so with that, good luck on all the studios.